This presentation is about runoff measurement using flumes. Practical number 6 is runoff measurement using partial flumes, and practical number 7 is runoff measurement using H flumes. We have seen previously in the subject of fluid mechanics different methods to measure the runoff or discharge. So first method for measurement of discharge is area velocity method. That means anyhow you measure the area, you measure the velocity, so multiplication of area and velocity you will get discharge or runoff in meter cube per second. Second method is volume and time. That means you note the volume of fluid flowing for a particular time, so you will get meter cube per second discharge or runoff. And third method is the measurement of discharge indirectly, that means by different instruments or structure. So in fluid mechanics we have seen different instruments or structures like venturi meter, orifice meter, pitot tube, different kind of weir and notches. These flumes are another this kind of structure to measure the runoff or discharge in any channel. So if we say flume is a stabilized channel section for measuring the flow, they require very low head loss for operation. So examples of flumes are that means different types of flumes are partial flume, H flume, cutthroat flumes, long throated flume and venturi flume. These are the different types of flumes. These flumes work according to the principle of venturi meter. The most of the flume has a shape similar to the venturi meter. Venturi meter, if you recollect your memory, venturi meter works on the principle of Bernoulli's theorem. What is the statement of Bernoulli's theorem? Sum of pressure head, potential head and elevation velocity head is constant. So pressure head, that means P, plus velocity head means V square upon 2G, plus potential head means Z. That means for suppose say 2 points in a channel, P1 plus V1 square upon 2G plus Z1 is equal to P2 plus V2 square upon 2G plus Z2. So now suppose at section 1 the size of section is high, and that means area is high. At section 2 area is low. So the section 2 where size or area is low, velocity will be high. That means velocity head will be high. At point 1 velocity head will be low. So at point 1 velocity head is low, so pressure head will be high. At second point velocity is high, pressure head will be low. That means between these two there will be difference of pressure, and by which we can indirectly measure the discharge. How, that we will see in next slide. So suppose if you say this is the partial flume, in which partial flume has 3 sections, same as in case of the venturi meter: converging section, throat and diverging section. Converging section means section which discharge diameter is reducing. Throat means constant diameter but the lowest size, and diverging section means diameter is increasing. Here HA, HB and HC are the points at which we have to measure the height of water surface elevations. This is another figure, measuring point, that means HA, where we should measure the height of water. If you see this second figure, this is the water surface level. So here in crest section also at different point there will be different height. So HA means what? That means point at which point in the crest we have to measure the height. So we have to measure the height 2/3 x from the throat. That means suppose this length is say 10 meter, then we have to measure this height at point 20 by 3 meter from the throat, that means 20 divided by 3, whatever the value comes, that much meter distance from this throat line we have to measure the HA. So this figure is about the measuring point for the Parshall flume. These are the another figures of Parshall flumes which are installed in the field. Here we can see converging section, throat, and diverging section, and these two are the scales, measuring scale to measure the discharge HA and HB. This is similarly when flume is installed in the field. So if you see the size ranges from 7.5 centimeter to several meter in throat width. In short, suppose if we want to buy a tractor, then how we can specify? We can specify tractor by HP, that I want to buy 25 horsepower tractor, 40 HP tractor. Similarly, Parshall flume is specified by the size of throat, that means diameter of throat. So these are the based on the size. If 25.4 mm to 76.2 mm, then we can say it is very small, similarly small and large. So depending on the size of throat, we can classify the Parshall flume according to the size, very small, small and large. Now discharge through flume can be measured for two conditions. One is the free flow condition and another is submerged flow condition. So free flow is when downstream water elevation affects or retard the rate of discharge. That means suppose this is the level. Now water is coming to here, it again retards the motion of this, or it is affecting the previous elevation. That means this is the converging section, diverging section, throat. So the downstream water, if it is affecting the flow at this section, then we can say this is the submerged flow. So here if we see darker side, so this is the submerged flow. That means initially the flow level height was this much, but due to this water the flow increased up to this. So this case is known as submerged flow. And another thing, free flow, that means if we remove this darker section, then here the downstream section has no effect on this upstream side of this line. So this is known as free flow. Now for better accuracy or better measurement, always it is desirable that free flow condition occurs. That means the downstream side will not affect the upstream side. So if the condition is free flow, then we have to measure only this height, that means HA. But if the condition is of submerged flow, then we have to measure this height also, that means this elevation of water also, that is called HB. So this height is HA, this is HB. If it is a free flow condition, then only if we measure this height, then we can measure the discharge. But if it is submerged, then we have to measure this also. Now when free flow condition will be there, so that is depends on submergence ratio, that means HB upon HA. So we have seen in previous slide point at which HB is measured and point at which HA is measured. So for the different width of throat, there is a specified value of HB by HA, this ratio. Suppose the width of throat is 2.5 to 7.5, this ratio is 0.5. If this ratio is greater than 0.5, then we can say this is the not free flow condition, but it is a submerged condition. Similarly, 0.6 for 1.5 to 22.5 centimeter, and 0.7, this is not 7, but this is 0.7 for 3 to 24 centimeter size of throat. So another thing, for practical purpose, we have equation also, but for when we purchase any flume for someone, the manufacturer supplied the calibrated curve. In that curve there is a two axis. In one axis there is h, height, and in another axis there is discharge. So just we have to install one staff, we may measure the height, we can get directly discharge for that particular flume. Or we can measure the discharge if we don't have that calibrated curve by this equation also. So this discharge is Ch raised to n, in which C and n are the coefficient which depend on the size, h, and various other conditions. And we have to do lots of practical 10, 50, 100, by which we can find the size of value of C and N for particular throat. So once we know the C and N, they are constant. For a flume, for a location, we can measure the discharge by just knowing the height. Now, advantage of this over various other structures or instrument to measure the discharge. So when total head drop is very small, at that time it can be used. It is its operation is independent of approaching velocity. That means if velocity high or low, its performance does not change. And it is a self-cleaning device. That means suppose in water, if there is sand, silt deposition, or these particles are there, so it is not accumulating in the structure, because it is a velocity, it is high, so it is a self-cleaning device. Another, now regarding this previous were about the flume, how we can measure the discharge. Now installation, that suppose there is a channel in field, I want to measure the discharge of this channel. So in entire channel, where and how we can install this Parshall flume. So first is the upstream condition, then crest and downstream channel. So first, if we see upstream condition, so this condition should be maintained at the time of installation of flume. So number one is, we should install the flume at the point where laminar flow condition is there at the flume inlet. That means we should not install this flume at turns, tees, elevation drop, obstruction, or this kind of things are there in channel section. At this obstruction, this flume should not be installed. Another, upstream channel slope should not allow excessive velocity at flume. That means abrupt, no change of velocity should be there. Then flat to maximum 3% slope is there. At that point we have to install. And if the flume is small, and if flume is large, then maximum 2% slope is there. At that point we have to install the flume. These are the ideal slope value. And a 1:4 sloping ramp upstream should be provided for the flume that must be installed above the channel floor. So if you want to install above the channel floor, then a ramp, that means a slopy structure, should be provided, one horizontal and 1:4. That means 1 vertical and 4 horizontal. This should be provided. Now crest of the flume. So it is a very general that floor of the converging section where depth measurement are made, so it should be leveled. Both, that means linear and sidewise, crest should be level. Another last is the downstream channel. So downstream channel should not permit submerged flow condition that we have already discussed. So we have to install at that places. Then long, narrow, flat or underside channel can result in the backwater effect. So it is the same as previous. And a large fall or steep slope immediately downstream of the metering section can eliminate the possibility of submerged flow condition. So in short, this third point is about the submerged flow condition, or in another word we can say water from the downstream section should not affect the water to upstream section. That means when water has been gone out to the Parshall flume, that water should not affect water which is inside our structure of Parshall flume. That is for downstream channel. Then for crest, only one thing, that it should be leveled. And for upstream condition, there are 4-5 things. One, laminar flow should be there. Second, that means in short, laminar flow means no turn, tease or obstruction. Another is velocity, and third is slope. So these three are the main important thing for installation of Parshall flume. So Parshall flume should be installed where all these conditions are satisfied for its better performance. Now there are some advantages and disadvantages which are a little bit covered in previous slides also, that minimum drop in pressure, measurement of large range of flow. So we have seen small size and larger size. So there is a large variation in small size, what was the width of throat, and large Parshall flume width of throat. So the high range of flow we can measure. Then self-cleaning device and reliable measurement in free flow and submerged flow condition. But a disadvantage, or we can say little bit care we have to take only in installation. That is this 4 points suggest only one thing, that accurate installation should be there. That means all the conditions in previous slide should be satisfied for a good performance. Now second type is H flume. So H flumes are device to guide the natural flow to converge through V-type cross section. In H flume, the high flows pass at the wide opening, whereas the low flow, the opening is reduced to maintain the sensitivity of the measurement. That means if the wide opening is used where the low flow is there, and when the high flow is there, the opening should be wide, and when low flow is there, opening should be reduced. So it is very simple. Another, the range, that means it can measure varying flow as high as 100 times the low flow accurately. That means suppose suppose a flume is there, so it can measure 1 meter cube per second and 100 times higher. That means 100 meter cube per second accurately. That means this much of range it can cover to measure the discharge accurately. So this is the another view. By previous figure also and this figure also, you can see it is a combination. H flume is a combination of physical and mechanical characteristics of weir and flume. Because if you see is this part, you can see as a resembles to the triangular weir. So here in previous Parshall flume there were 3 sections, converging, throat and diverging. Here only 2 sections are there. One is the approach section which is converging, and another is control section which is a opening, which is just like a triangular weir. So here in case of H flume there are only 2 sections. One is approach section and another is control section. These are the another figures of Parshall H flumes installed in the field. So you can see the 2 sections. First is approach section and another is control section. Now H flumes can be classified in 3 types: HS, H and HL. All these are depending on the size. HS means small, H means medium and HL means large. So S means small, H means medium and L means large. So depending on the size we can classify, same as in case of Parshall flumes, small, medium and large. So here also HS small category, so depth is restricted to 30 cm and it can measure the flow 0.005 to 23 liter per second. So this all is the dimension. Okay, what should be the depth and what is the range of discharge. Similarly for H flume, that means medium, so here depth is 1.4 meter and we can measure 0.01 liter per second to 2400 liter per second discharge. Similarly in case of large, maximum flow depth is same as H flume, but here it is wider than H flume. So what is the difference between H flume and HL? That limitation of depth is same, 1.4 meter, but here it is wider as compared to H, so it can measure the more discharge, so it can measure up to 3300 liter per second discharge maximum it can measure. So now this table is about the H flume, H, HS and HL. Based on the value, what are the specified height, width, length and spot. This SPOUT, spot, is the outlet. If you recollect the previous figure, we have at the last very small channel, that means small outlet. That outlet is known as spot. So first table is different ratio of width and height, length and height and spot and height. So in HS flume it is 1.9, 1.35, 0.1 H flume and HL flume. Another first table was ratio and second table is actual value. So suppose H flume comes under 9-10 different combination. That means these are the different variation. In this much variation we can get the H flume. So suppose if height is 0.5, width 0.95, length 0.68, T 0.05. So these are the standard sizes of H, HS or HL flume which are available. So suppose if we say H by T, in previous table or first table we can see H by T is 0.1. Similarly in all the flume we can get all the HS, T by H 0.1. Similarly W by H, if you do, it will be 1.9, L by H you will do 1.35. So in short, in all the size of HS flume, ratio of W by H should be 1.9. ratio of W by H, that means width by height for H film should be 1.05. Ratio of W by H for HL film should be 3.5. So here you can see for HL film width is 3.2 times higher than height. Here it is 1 time higher than height. It is 1.9 times higher than height. So these are the different standards regarding the different sizes of H film. Now, as in case of a Parshall film, there were three different types of operating principle. That means how it should be installed and how it is functioning. So operating principle, it is same as Parshall flume, that is based on the Venturi meter, or we can say Bernoulli's theorem. Now, due to the lateral restrictions, the flume restrict the flow area, causing the water level upstream from the throat to rise. So this is a, that means suppose the water is 1 meter width of channel is there. Suppose if from 1 meter, if you directly convert into the 0.7 meter width, then water level will rise. So this sentence is same. Now flow can be obtained by simply measuring the water depth, because the depth varies proportional to width of flow. That means suppose a 1 meter width channel, if we convert or if we install H flume whose width is 0.7, that height will be rise, and by measuring this height we can measure the discharge. Now here it is strongly recommended that as in case of Parshall flume, here also that free flow condition should be there for its better performance, and flow measurement can be done by only one point if it is a free flow condition, but if it is a submerged flow condition, then depth of downstream from the throat section must be also measured. Similar as in case of Parshall flume, that if free flow condition is there, only HA, if submerged is there, then HA and HB both we have to measure. Here also if free flow condition, only one measurement. If it is submerged, then at the downstream also we have to measure the height of water. Now H flume was developed to measure the flow of irrigation water from small catchment areas and surface water. That means in short, suppose water is coming from large area, so we have to collect at one place and measure the discharge. It is also used to measure the flow of irrigation water, slow flowing water courses and water in sewer system. And if some solid particles are also there, that may be used to measure this. H flume can be used to measure this kind of flow also. Another one advantage we can say, easy to manufacture, inexpensive and suitable for temporary measurement system. Now some points about installation of H flumes. So it is a very easy. When flumes are installed, the approach boxes should whenever possible be placed below the natural ground surface. Where the watershed or slope is small and the flow is dispersed, gutters may be provided. That means suppose if we want to measure the discharge in a plot, and if we do not get the all water of that plot at a particular point, then we have to suppose install 3, 4, 5, 6, 7 small channels, collect the entire water of all these channels, or we can say gutters, to one point, and then after we have to install the H flume, so by which we can measure the discharge of entire plot. Another 3 3-4 general points are there. Metal flume should be fixed to the concrete approach. The concrete cutoff wall should extend below the concrete approach at the upstream face to provide substantial support and prevent the seepage. So this is the for the structure, for the strength or stability, the flume floor must be level. If the silting is a problem, 1 in 8 sloping falls floor can be set to concentrate low flows and thereby reducing the silting. That means if velocity is low, in short, if velocity is low, we have to concentrate the flow, so discharge will increase and the silting problem became remain. Another last cut throat flume. So we have seen in partial flume there were 3 sections, converging, throat and diverging section, but here only 2 sections are there, converging and diverging. No throat is there. That's why it is known as cut throat flume. The cross section of this may be rectangular, trapezoidal, triangle, depending on the availability of appropriate calibration or seeing the condition. Now this is the equation for measuring the discharge of cut throat flume. C1 HAN multiplied by L. Q is the discharge. C1 is free flow coefficient, which is the value of Q when HA is 1 foot. So what is C1? When height is 1 foot, C1 is equal to Q. And L is the exponent, whose value depends only on the flume length L. So C1 and N are the coefficient, L is the length, and HA is the height we have to measure. So this all were about the flumes to measure the discharge of a channel.